Hi, ladies and gentlemen. So after our previous video, I believe that you'll have at least a basic sense of how differentiated inverse functions in AP Calculus is done. So today we are going to continue our study of differentiating inverse functions, and we are going to study in particular the inverse trigonometric derivatives formula. So in this video, I'm going to provide or introduce two of these rules. So yeah, let's get started, and hopefully we're also going to prove them. So the first one states that the derivative of arcsine, which is the inverse of the sine function, is equal to 1 over radical 1 minus x squared. And the second one states that the derivative of arc cosine, the derivative of arc cosine is equal to negative 1 over radical 1 minus x squared. Okay? So let's start with the first one. Now, these two proofs are rather easy for us. It's different from like previous videos where we start with the definition of derivatives. We are just going to straightforwardly approach this derivative. So what we're going to do first is we're going to start with the basic equation for y. So for this function, the arcsine function, we have sine of y is equal to x. Okay, because we know that y is equal to arcsine x, and because arcsine is basically the inverse function of sine, what we can do is just change the xy values. And so this is what we get after that. Now we can differentiate both sides, okay? So on the left side, the derivative of sine of y, as we know, is cosine of y, okay? So cosine of y. And now don't forget that when we're learning the chain rule, we always remember to times dy dx because y is a function of x essentially. And now on the right side, we only have 1 because the derivative of x is just 1. Okay, now we divide both sides by cosine of y, and therefore we get dy dx is equal to 1 over cosine of y. Okay, and now we are going to use a very, very basic identity in trigonometry that it's basically the first couple of things we learn in trigonometry, which I believe you guys are really familiar with, is that sine squared y plus cosine squared y is equal to 1, okay? And so by this identity, we are going to isolate cosine of y so that we can substitute inside this function, and because sine y equal to x, we can get a equation that only has x, okay? So isolating cosine of y, we get cosine of y is equal to radical 1 minus sine squared of x, okay? And let's substitute cosine of y into our dy dx, and so we get 1 over radical 1 minus sine squared of x. And now because sine y, this is actually sine y, sine squared y, okay? And now because sine y equal to x, we can substitute x into our dy dx, which we get radical 1 minus x squared. So our final answer is 1 over radical 1 minus x squared. Thus, we have proven the first rule. And before we start the second rule, I recommend you to just stop the video and try this by yourself because the proof is rather really similar to the first proof. But if you can't, that's totally fine. Let's do it together. So we're going to approach the second one with exactly the same method. So here we have cosine of y is equal to x. Now differentiating both sides, we get negative sine of y times dy dx is equal to 1. Now dividing both sides by negative sine of y, we get dy dx is equal to 1 over negative sine of y. Okay, and again by the basic identity, which is sine squared y plus cosine squared y is equal to 1, we get sine y is equal to radical 1 minus x squared. Substituting this into our derivative, we get 1 over negative radical 1 minus, this is not x squared, this is cosine squared y, with 1 minus cosine squared y here. And again, because cosine y is equal to x, we can again substitute x into our equation, and so finally we get 1 over radical 1 minus x squared. Now don't forget the negative sign. And so we have finished the proof for both of the rules. So I hope you enjoyed today's video, and hopefully I'll see you in the next session.